there's so much content that sometimes it's hard to get through it in a 50-minute or 55-minute class period. So there is some of this factoring stuff that you could have seen examples of there. And so if you do get stuck in the homework, that can be a valuable resource. So let me do some of the factoring that I didn't get to last time. So let me just say some more factoring. So you need to be the master of factoring quadratics. So that you have to be very skilled on. And if you aren't, let me know, because I can get you some extra practice on that. And I can show you how to do it as well. Remind you how to do, I think most of us in here have learned it, the box and diamond strategy. There are others as well. But that cannot get in the way of you doing other stuff, because factoring is not our purpose in here, but we will use factoring to do lots of other things. So if you don't factor quickly and accurately, it just gets in the way of other things that we're trying to do. There are some other kinds of factoring. So one is to factor by grouping. And so I think you saw this in algebra 2. So if you have something like, say, x cubed plus 3x squared minus 4x minus 12. So anytime you have something that's more than an x squared, so a higher degree, a higher order polynomial than a quadratic, then something has got to give here. We have to have some special properties of what we're facing. And a couple of those are going to be to get a greatest common factor first. And in this case, the other strategy we know to date is going to be to factor by grouping, and we'll get some other strategies as we go on. So the idea is we pair these up, and then we factor out the greatest common factor out of each pair. So between the first two, the greatest common factor is x squared. And that will leave behind, after we factor an x squared just out of the first two terms, is going to be, thank you, I thought I was going on myself for a moment there. In the second two terms, the greatest common factor is -4. And at this point in time, now you know what you're looking for. So since we got an x plus 3 there, if this strategy is going to work, what's left here has to be identical. If we can't get it to that point, then this strategy isn't going to work. We're going to do something else. And right now, we don't have anything else, so it better work. So here, when we factor that out, we also get an x plus 3. So now we have an x plus 3 times this, an x plus 3 times that. These two terms have a common factor of x plus 3. So we will factor that out. Now notice that is not an x plus 3 squared. It is one x plus 3 factor that's coming out of each of these. Does that make sense? Why that's not x plus 3 squared. Okay, and then what's left behind is x squared minus 4. Now sometimes this will be the end of the road, but in this case, we can factor x squared minus 4 more. It's the difference of two squares. So we will continue and factor that into x minus 2x plus 2. And difference of two squares should be like an automatic. We have to recognize that and be able to get that quickly and easily. So there is our factorization. Okay, that's called factor by grouping. And there's some more examples on the video, like I said, the support video. There are other things, sometimes we're going to look for. The GCF stands for greatest common factor. So you're always on the lookout for that. So finding and recognizing and factoring out the greatest common factor just makes your life much easier. So for example, if we have a 2x cubed minus 2x squared minus 12x. So here again you see a cube, you get a third degree polynomial. So we know, we're heightened alert here because our normal strategy of box and diamond doesn't serve us well here. But you can see these all have a greatest common factor of 2x. So we'll pull the 2x out first. And then what is left behind, hopefully, is more recognizable. the x squared minus x minus 6. And now you can do your box and diamond, or I don't know if you guys know guess and check, or whatever quick and accurate way you can do this. So this shouldn't be a great, well, an adventure or an ordeal. It should be a routine. If it isn't, we need more practice. And then the next stage is, after we do what we want to do sometimes with this factoring, and what we're going to use it with in terms of, our graphing of quadratics is to solve these equations. So we use the equations, we use the factoring as a means to solve that equation as quadratic. So if we have x squared minus x equal to 12, then remember, when you have an x squared, unless you have no x term at all, none of those middle terms, where you can just isolate the x squared equal to a number and take the square root of both sides. If we don't have that situation, then what we want to do is make it equal to 0 so that we can factor it. So people that try to factor it here and factor out the x with it equal to 12, that's not going to lead to anything good, because we don't want two things that multiply and less you to be a non-zero number, because now it doesn't tell us anything about what A and B have to be. There are an infinite number of choices for what A can be and B can be multiplied to be 5. But when we get two things that equal multiplied to be 0, now we've narrowed it down. Either A is 0 or B is 0 or both. But it's only helpful if it's equal to 0. So you have to always start by making it equal to 0. Then you can factor that so that you can get two things that multiply to be 0. And I'll let you do that and tell me what we get. So does anybody do it other than box and diamond in here? Or we just all box and
I usually skip the diamond step.
so you can go right to the box thing. And being efficient and doing it quick is a total benefit. I think I'm all in favor of that. You don't have to show me lots of work or any work, as long as you can get it accurately. But if you can't get it accurately, then speed is no help. Getting to the wrong answer quickly has no advantage to it. Okay? So what do we get? Oh, did I get one that doesn't
It
factor?
doesn't. If it was a positive.
Let's do that.
Yeah.
We're gonna take the liberty of changing the problem midstream because I really don't want to do quadratic formula. But okay, I can do that. I'm the boss in here.
It would be x minus 6 times x minus.
Okay, that's what I was hoping for. So then we set each of these equal to 0. Right? So what we have is two things that multiply to be 0. Therefore, one of those must be 0. And so x can be either 6 or 2. So we have two possible solutions. Okay? So, good on that. Any other questions from the homework? What would you like to see done?
61.
61, do you know what that is?
Yeah, it's like x squared times e to the negative 3x.
Oh, crazy.
And then plus 2x e to the negative 3x.
Just like that?
X on the end of 3. Negative x.
Is that an x also then?
Yeah.
And that's equal to 0? Oh, no, there's more.
I think so.
I bet there's one more term. Is that it? Oh, okay. So, yeah, and the e to the negative 3x is a little bit disconcerting there. But notice, since it appears in both these terms, we can factor it out as the greatest common factor. And that's the key. So if we pull that out, now it starts to look a little bit more familiar. So now what's left is,
X squared plus 2x.
right, okay? Well, let's keep staying on our theme of factoring. X squared plus 2x has the greatest common factor of
X.
x. So I'm going to, just to kind of distinguish between these two factors there, I'm going to put a multiplication dot in between them just so you can see it a little more clearly. So now what we have is 1, 2, 3 things that multiply to be 0, which means one of these three has to be 0. So now what we do is we're going to try to set each of these equal to 0 and solve. Does that make sense? So I'll do this one. X is 0. What's this one going to be? What's this one? Where is e to the negative 3x equal to 0?
No, because it's that's 0 and it's e to like the 0 which is 1.
With your finger in the air, what does the graph of first e to the x look like? Do you know? It's an exponential growth curve. So here's e to the x, right? This, so there is y equals e to the x. So 3 to the x, e to the 3x would just be a vertical stretch. We haven't really talked about that, but from before. The negative is going to do what?
It's going to flip it across the
Flip it over to y, right? The negative in front would flip it in the x. The negative in the exponent is going to flip it there. So where's this equal to 0? Where does it touch the x-axis? It does not. So this is always positive. So there is no value of x that ever makes this equal to 0. So this contributes nothing. It's just something that really makes this look complicated and hard, but it really doesn't affect us. So we have two solutions, 0 and negative 2. Okay? Oh, as if life isn't complicated enough. Right? Anything else? Okay, so we are going to, we're going to do this kind of quick. So we're talking about parabolas, remember, and we did the, we found the vertex last time using x equals negative b over 2a. And we did that using a parabola that was in standard form, y equals ax squared plus bx plus c. So now we're going to look at a parabola that's in factored form. So by that, I mean it's going to look like y equals some number a, possibly, x minus r, x minus x. So it's like all the stuff that we were just spending our time doing here at the beginning, trying to do the box and diamond and factor it and all that, has already been done for us. So it's given to us in this form. So we are going to see how we can take that and run with it. So we're going to graph, I'll do an example here, y equals negative 2 times x plus 2 times x minus 1. Now we're still looking for all of those things that we always do when we graph. So we're going to find, maybe not in this order, we're going to find the vertex, we're going to find the y-intercept, we're going to find this weird point that we are calling the symmetric point. We are going to see D, we're going to find the x-intercepts, which lots of times is difficult, but in this case is going to be like exceptionally easy because it's gifted to us. And then we are going to put in the axis of symmetry. Okay, those are the things that we do when we try to graph a parabola, most of the time. So in this case, rather than jumping right to the vertex, the low-hanging fruit, the thing that is right there for us to find, is going to be the x-intercepts. So we're going to start with that. So to find the x-intercepts, we just set this equal to 0. Well, it's already factored. So what are the values of x that make that equal to 0? Negative 2 and positive 1, right? So x equals negative 2, x equals positive 1. So our x-intercepts are going to be negative 2, 0, and positive, scale that about the same, and positive 1, 0. So what is oftentimes a difficult thing to find, particularly we have to use quadratic formula, in the case where the equation is given to us in factored form is really simple. It's right there. So now what we want to do is, let's find that vertex. So when we look at that, knowing the symmetry of a parabola, where is that axis of symmetry, that line that's going to cut it right in half? It has to be halfway in between these, right?
Negative 0.5.
Yeah, so these are 3 apart, so we have to go over 1.5. So there's 1.5 is going to be right there. So here is our axis of symmetry. That is going to be x equals, what's that number? negative 1/2. See it? Now that then is also going to be the x-coordinate for our vertex. Our vertex has to lie on the axis of symmetry. Does that make sense? So now we got to plug it in to get the y-coordinate. So we get y equals -2. Then I'm going to plug in -1/2 plus 2, -1/2 minus 1. See where I'm putting that? I need nods of heads. Okay, see how I'm doing this? So now, oh goodness, we have to deal with a little bit of fractions here. No tears, please. -1/2 plus 1 is going to be 1/2.
It's
Can I-
plus 2, -1/2.
Okay, -1/2 plus 2. I can be flexible. It's going to be how much?
3/2.
1/2, 3/2 is going to be helpful for us. So we call 3/2. And -1/2 minus 1 is going to be a -3/2. So when we multiply fractions, we just, well, we can cancel one of those if you're not opposed to canceling. We'll reduce up front. So we're going to get 1 times 3 times -3 is a -9. 2 negatives is going to be a +9. And then 1 times 1 times 2 is 9/2. You okay with that? Check me on that. It's early in the morning. So that's going to be a +9/2 or 4.5, either way. So we're going to go to, let's see, 1, 2, 3, 4, 5, halfway in between. What I call there is our vertex, -1/2, 9/2, or 4.5. Okay? What else do we need? Y-intercept. How do you find a y-intercept?
Set it equal to 0.
To get the x-intercepts, we set it equal to 0. To get the y-intercepts, we're going to
Well, the x is 0.
plug in 0 for x. Okay? So to find the y-intercept, we'll get y equals, we got -2, we're going to go 0 plus 2, 0 minus 1. See where we're getting that from? Sticking in 0 for the x's. So -2 times 2 times -1 is going to be 4. So that makes our y-intercept 1, 2, 3, 4, 0, comma 4. Okay, just down a little bit from that vertex that was at -1/2, 4.5. And what you got line? You okay with that? Wait a minute.
Oh, wait, never mind.
Okay. Symmetric point. Other side of the vertex from the y-intercept is going to be where?
-1.
Good. And y-coordinate? Same as the y-intercept. Okay. So -1, 4, and that's our symmetric point. And then we got it. Okay? Make sense? Okay, we're going to change gears. We'll do a different kind of problem. I ask you to find an equation of a parabola that has some characteristics. So find an equation, so I don't care what form it's in, of a parabola with, and then I'm going to say these characteristics. Y-intercept, I will tell you, is 0, -3. And x-intercepts are going to be 1, 0, 1, 0, and 4, 0.
That's it.
That's it. But that's enough.
That's enough.
So, how do we start? If you're given x-intercepts.
Probably should graph them.
Oh, we don't even have to graph it. What's the form of our
So,
equation?
you know it's going to be x minus 4 and x.
Okay, so we're going to start with, we're going to use our factored form. So this is our, kind of our template. This is what we're starting with. Now, what do we know? To start with, Aaron was saying, well, we don't know the a. If we have x-intercepts 1 and 4, then that's going to make the x minus r, x minus s be what?
X minus 1, x minus
Exactly. Now, we still don't know A, but we haven't used this y-intercept. How are we gonna find what the A is? We plug this in for x and y, because the value of x and y has got to make this true. So negative 3 is A times 0 minus 1, 0 minus 4. You with me there? Okay. So that's going to be negative 3 is, let's see, negative 1 times negative 4 is positive 4. We have 4A equals negative 3. So I guess that means A must be negative 3/4. And so then we know the final piece. So our equation is going to be y equals negative 3/4 times x minus 1 times x minus 4. Now, I didn't say it had to be in standard form, so it doesn't say it must be in standard form. There's no point in multiplying all that out. It's a lot of work for no real gain. Let me give you a different one. Same idea. Can I just show you the evidence here? Okay, so this time we're going to say we have, instead of saying x-intercept, I'm going to say this has zeros at 4, negative 3, and contains the point negative 2, 1. And with that little bit of information, you can actually find an equation. What do I mean by zeros? That's another word for x-intercepts, right? It's going to be what makes that parabola, that equation equal to 0. So again, we're going to start out with A times, what's it going to look like this time? Minus 4, x plus 3, exactly. Good. I didn't give you the y-intercept this time, but it's still a point on the curve. So it's still a value for x and y that has to make that a true statement. So we can plug that in and find out what the A is. So we're going to put 1 in where the y is. Negative 2 for both of those x's. And so let's see, negative 2 minus 4 is going to be a negative 6. Negative 2 plus 3 is going to be a positive 1. So we have negative 6A equal to 1. Am I going too fast? So A is going to be negative 1/6. So our equation is going to be y equals, there's the negative 1/6, and the rest can stay as it was. All right. Well, there's some other crazy kind of problems. This is the part of it. If you find you get stuck, there's a couple more examples on the support video. If you scroll all the way to the end, you can see some suggestions on how to do that. All right.